And actually, all this stuff can go in the case structure. So create a case structure here that says, okay, if the average is above, then we can say the data is good. In that case, we will take the new data. I'm going to go find the new data here. If I can never find this stuff, I don't know what message it's in, I can also just come out here, double click on it, and Labview will show me where it is. So I can create a local variable and say, okay, well, if the new data is good, then I will use build array, and I will take all data, and I will put the new data onto the end of it, and I will put that back out to all data, so all data will grow, and I'll put that to the graph as well. So now, I should be able to get some data, process that data, and again, I'll get and process, and then this one looks good, so I can add him, and that's only one. So we got 20, we got 1. I guess we're going to need some more data. And what's going on here? Autoscale Z. All right, now we got some stuff going on. So, so sure enough, this is random data, but we can go back through here, and I can just click these buttons in sequence. And if the data is valid, then we'll get more data onto our intensity graph. So this is working great, and we're sort of gathering in rows of data, processing them, adding them to the graph. And so this is really, really useful and shows the power of our event structure. But if you find the user clicking these things all in a row, then that seems like a great thing that we could try and automate. So let's do one more, which is we'll create a button called auto run. And what auto run is going to do is I'm going to remove the mechanical action so he can actually stay pressed, and he'll just click these buttons in sequence, but not too fast. So, so what I will do then is I will say, okay, if we get a timeout, this is a great opportunity to use the timeout. So if we get a timeout, then what I can do with auto run, I can say, all right, well, if auto run is true, if auto run is true, then let's send some messages. So notice that unlike before, where all the messages were coming from the event handler, which were driven by user operations, now if the auto run case is true, the message handler can send itself messages. And so then, whoops, what I want just the enqueue message. And I'm going to do a little trick here. I want to send it 3 messages, so I'm going to put the enqueue message into a for loop. And then outside the for loop, I'm going to make an array of messages. And so if auto run is true, I'm going to want to first call get data. And then I will call process data. And I'm going and grabbing the text straight from the top of the case structure. It helps me. So if I make a typo here, oops, there you go. I did make a typo. I pasted it in twice. If I make a typo, then the event's not going to run, because these things actually need to match exactly, because we're dequeuing a message that's just text, and then we're matching it up against a case structure. So if I have a typo in here, then it's not going to work at all. And so I'll get a different message. And then by the fact I won't see my message run, I probably won't have too much trouble debugging that. And I'm going to put a delay in here just so this thing doesn't run too fast, and we'll have it run every half second. And then I'm going to wire up my messages here, and my program is ready to run. In fact, actually, I think we started the program anew, so got to get a good data set here to see if the graph is going to clear for me. There's one. And sure enough, that when I start the program, so maybe I might want to add another button that clears the graph out. But here's auto run working through, and so now we can see that this thing is running on its own. And so this shows how I can use a message handler to create fairly, it's fairly simple to create, but fairly complex program, and then I can use the message handler to call its own messages and automate that function. So So this is an example of event structures and message handlers in LabVIEW. That's helpful.